So voltage is a measure of how much energy your charge possesses. So it's that voltage that things in your circuit need to run. They need that energy. So you plug a battery into something, or you plug it into the grid, and the current carries energy and carries an energy on its charges to supply those. So voltage is a measure of the energy carried by the charges in a current. Okay. So it's measured in volts. Voltage is measured in volts, not to alarm him. 1 volt equals 1 joule, which you'll remember is our unit for energy, per coulomb, which is our measure for charge. Okay, so 1 volt is 1 bit of energy to 1 coulomb. It's quite a lot of electrons, yeah. So to get 1 volt, you're spreading 1 joule over whatever we said before, 6 times 10 to the power of 18 electrons. So if you touch an individual electron, I don't even know how that would work, but if you could touch an individual electron, probably you would not really feel anything noticeable in terms of current or voltage, because the numbers are much, much, much too small. Correct. So if you think about batteries and things then, so a 12-volt battery will give out 12 joules per every coulomb that goes past it. Okay. So if you're thinking in the context of a circuit, of a power source and then a lamp or a radio, whatever you're trying to run, the electrons moving around that circuit create a flow, create a current. So their movement is the current. The electrons are carrying energy, are carrying that voltage, and they're resisted or not depending on what they're going through. So from woe to go, the same current is going to go through the circuit. The current all has to end up at the end. You can't sort of lose them part way, but they spend all their voltage. So by the time an electron leaves the battery and then gets back to the battery, it will give up all of its volts. Okay, but the same number of electrons will keep going through. When I do electricity, I imagine small people with wheelbarrows as my electrons, and 50 wheelbarrows or however many wheelbarrows leave the battery and 50 come back, and they start off with a certain number of volts, which can be whatever I imagine fruit, because fruit seems friendly to me, in the wheelbarrow, and they give out fruit to the different things as they go through, and then they end up with no fruit at the end. So next week when you're thinking about circuits, not next week, sorry, next lesson, when you're thinking about circuits, that may or may not be helpful to you. Certainly in a test or an exam, you don't have to talk about the people with the fruit, but if it's a helpful way of visualizing things, you can do it. Otherwise, in reality, what's happening is there's a flow of electrons, each of which has been allocated a certain amount of energy, so there's a voltage associated, and that voltage gets spent around the circuit. Okay. So these are kind of the key things, like the basic building blocks of electricity, is understanding the idea of a charge, about what's actually moving around, how it moves, how it's stopped or let through, and how much energy it has associated with it. And we can tie those all together using something called Ohm's law, which is really, really useful.